So we have 2 points in the plane. Think of a membrane that propagates disturbances at some velocity, same velocity in every direction. Propagation speed c, and we drive each of these points with frequency f simultaneously. Okay? We're going to assume that the wavelength that results from this is a whole lot less than a. These points are separated by distance a. This one half that distance above, this one half that distance below the x-axis on the y-axis. And then we ask the questions, what's the relative phase at position x on the x-axis? So just take some position x, okay? Figure out the relative phase. That one's pretty easy. Position y on the y-axis, okay, which is going to depend a lot on the parameters of the situation. And where on the line of angle alpha is the relative phase 0, and if it isn't ever 0, then for what angle alpha would it be 0, if any? And the other thing I probably should have stated, at a distance much greater than a, just say from the origin, because then it's certainly going to be at a distance much greater than a from either of these points, right? Okay? How would we answer these questions? So we've seen that if I give you a point out here somewhere, give you the coordinates, the thing that determines the relative phase at this point, or the phase at this point relative to the phase of this source, is this distance, right? And what determines its relative phase from here is this distance, right? So what is it that determines the relative phases of the two disturbances when they first both get here and every time thereafter? Because once the disturbances both get here, it's just going to continue in the same phase, right?